Okay, so chapter 4 about physical connection that you guys have done many time in the lab. Okay, so it looks like some of you. So I will give you some explanation about. So it's about different type of cabling and connectors, and it's also called physical layer because it's physical. All right, so just a quick review of the OSI layers. What are the benefits of using a layered model? It simplifies the complex concepts of networking because there are many things are involved in networking. There are protocols, there are operating system, there are hardware devices. All this has to work with each other, right? So this whole process of communication between two devices is broken down into different layers. Okay, 7 layers, and each layer has a responsibility. So, what is the responsibility of physical layer? This is what we will discuss in this chapter. Okay, so these are the 7 layers, and they deals with different software and hardware that uses in the network. Okay,
Should you memorize them?
no, you don't need to memorize them. No, we'll talk about different chapter. No, you don't need to memorize them. Anyway, you will understand as we go along the course. You will just understand. So physical layer, as the name implies. So think. You see, I'm not a big fan of memorization. I prefer understanding things. Okay. So physical layer is easier to understand. Physical layer, anything that is physical, physical connection, cable, ports, connectors, right? Okay, so we'll talk about the physical layer. The purpose of the physical layer to create a physical connection between two devices, and it does that by using either cable, different type of cables, and also the wireless signals. Okay, so when you use your phone and you're connecting to your service provider, either you're with Virgin Mobile or Fido, whatever, when you're connecting with your provider, actually you're using the atmosphere, okay, as a medium to send signals. Okay, that's wireless. In a wired network, we have different type of cables, as you guys have seen, and this is what we will talk about. What are the different type of cables are there, and what is the different type of media is used in network communication. So the characteristic of physical layers are the hardware devices, media, and other connectors that transmit the signal that represents the bit. So what are so you remember the interface on a router, gigabit interface, serial interface, right? That's physical. That's correspond to physical layer. You remember all the cables in the in the Cisco lab that you guys have used, the crossover cable, straight through cable, the serial cable. These are all correspond to physical layer. All the cabling. Okay. All right. Bandwidth. I'm sure you guys know what the bandwidth is. Is the speed of the data that travels from one device to another device. Bandwidth is measured in bits per second. Okay. Not byte per second. A lot of people get confused. Byte per second is the storage. So let's say if you're describing the size of a hard drive, you say 1 gig per second. So that means it's 1 gigabyte, not 1 gig per second. 1 gigabyte is the space of a storage. When we talk about the signals traveling from one device to another device, the measurement is bits per second. So we have kilobits per second, megabits per second. I'm sure megabits per second in a local area network is obsolete. Most of the local area network now it uses at least 1 gigabit per second. I think internet connection is still megabit per second. Anybody has gigabit per second internet connection? No, eh? Okay. I don't know. My internet connection is, I don't know, something two, 300, and that's good enough for me.
Where we can verify this, Junaid?
Oh,
The speed.
it's with your service provider. When you subscribe to, oh, you will know that because you will pay a lot more for gigabit per second internet connection, okay? But if you're not sure, what you can do is, look, watch this. Have you guys ever seen internet speed test? Let's see what is so
Yes.
our internet speed here in the school is 591.4 megabits per second, but it doesn't mean that is the bandwidth. It's just right now, this is how much we are receiving. So the bandwidth could be 1 gig per second, but your real throughput, this is called throughput, the measure of the transfer of bit across the media over a given period of time, is only. So I know for the fact that the school board has 1 gigabit per second internet connection, but you see right now I'm not getting 100 megabits per second. Instead, 591, sorry, 1 gigabit per second. Instead, I'm getting only 591 megabits per second. It's because bandwidth, there are a lot of things can affect bandwidth. Some of them are like, for example, number of users are using the internet. Let's say if 100 people are using the internet, your internet will be slower compared to if only 5 people are using internet. Okay, so the throughput means the real speed of the network, not the total speed, which is the bandwidth. The good speed is throughput or the overhead. Latency means uh, 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 anything that slows down the network. What could slow down the network? Number of users, type of and also depends what type of data they're exchanging. For example, if you're watching videos, that would affect your network. It will create latency. But if you're just accessing websites with text, there that would not affect your network speed as much as if you're watching videos. So latency, throughput, and good throughput, these are the bandwidth terminologies. Okay. Okay, copper cabling. The copper cabling, the cable that you have seen in our lab, they're all copper cables, meaning the inside of the cable is, the core of the cable is copper, and they use electrical signal to carry data from one device to another device. They can be they are prone to EMI, which is magnetic interference that is created by other electronic devices. So if you're using a copper cable with a lot of machinery around, that can interfere with the speed of the network. Okay, all these cable has a minimum and maximum, a maximum length. For example, if you want to connect two network and they are more than 100 meters apart, you cannot use a copper cable. In this case, you have to use fiber optic. So this is something you have to keep in mind when you are setting up a network. Okay, the length and EMI interference. So this is your if you have Videotron internet connection at home, probably you guys are familiar with this cable, which is a coax cable that is used with cable network, cable internet, such as Videotron. These are the cable that you have seen in our lab. Twisted pair cable and shielded twisted pair. Okay, these are the cable that you have seen in our lab. Twisted pair cable, there are 8 wires in one cable that are twisted, so the signal cannot interfere with each other. Okay. Twisted pair cable use RJ45 connectors. So I believe you guys have made some cables with Dimitri. So this is the cable that you made, twisted pair that uses RJ45. Shield is twisted pair. If you look at the twisted pair, there's no shield. Shielded twisted pair has this shield. Okay? It protects from It protects the cable from outside interference. Shielded twisted pair is more expensive than unshielded twisted pair, like this one. And but you need shielded twisted pair only in an environment where there are a lot of machineries, like manufacturing environment or any type of lab with a lot of electronic equipment. Not the computer, but other electronic equipment. Okay? And this is coax cable. It also has the core, shield, and here, this is the core, sorry. This is all this three, they protect the core from outside interference. The connector they use are called BNC, N-type, and F-type. More BNC are the more common. Anybody has cable internet at home?
I was have one of it, but when I upgrade, or I have a fiber optic now.
Mm. If you have cable internet at home, you will see this cable and you will see this connector going into the modem. Okay, the purpose of the twisting of this wire is to cancel signal from the adjacent wire, so they won't interact with each other. They don't interfere. So that's it. This is called crosstalk. So keep that in mind. The only purpose to twist is so the signal cannot interfere with each other because each wire carries a signal. Okay? There are different categories of UTP cables. When you purchase UTP cable, you have to decide which category you need. Each category has different speed. Most recent category is, I think, category 7, and it's, I don't know, 10 gigabit per second. So you have to decide. Obviously, the higher category would be more expensive because it carries signal faster. So it depends on your budget. Okay, how much money you want to spend. If you want 10 gigabit per second, you need to go with category 7 cable, and obviously it will be more expensive. All right. The connectors that is used in UTP cables are called RJ45 connectors. This is how they look like. Okay, this connector is not good. Did you guys make cables with Dimitri?
Yes,
Okay, this is no good. How many of you probably did this in the your first cable that
me.
looks like this? Yeah?
Yeah, me.
This is not good. This is good.
Yeah.
So yeah. Okay, the question. Straight through and crossover cables. Straight through is used with two different devices, and crossover is
The same
used.
connect to the same devices.
Yes, very good, Michael. Now, look at this. And so, what is the difference between a straight through or crossover cable? Just one difference. A crossover cable,
The color. Yeah.
the color pattern is different on both ends. As you can see, one end called T568A, which is a standard, it starts with green, white, green, orange, white, blue, blue, white, orange, uh, what is it? Brown, white, and brown. And look at the other one. It's different. The first one is orange, white, orange, green, white, and blue, and so on. So that's the crossover cable. And a straight through cable would have both end the same color pattern. So if you want to make a crossover cable, all you have to do is just the other side would be same as the first side. So the other side would be uh, green, white, green, orange, white, blue, blue, white, and so on. So that's it. That's the only difference. It's not a different cable. It's just the color pattern is different from one side to the other side. That's all. Now there's a better cabling option which is called fiber optic that you guys must have heard many time. Oh, Bell Fibe or fiber optic connection. So what exactly a fiber optic is? The main difference between fiber optic and UTP cable is the core. Core is the medium that actually carries the signal. In fiber optic, the core is either glass, okay, or the fiber. Ok- Now, some of the characteristic of fiber optic is they can transmit data over longer distance, okay, at higher bandwidth. But now copper and fiber optic are almost the same bandwidth, but it's still over the long. So fiber UTP cable or copper cable can carry signal up to 100 meters. Fiber optic can carry signal up to 1000 meters. Okay. And fiber optic uses uh, light pulses as opposed to electrical pulses used by copper cable. There are two type fiber optic, single mode fiber and multi-mode fiber. Very small core, and the difference is single mode, very small core uses expensive laser. It is suitable for long distance applications. Multi fiber has large core, it's less expensive, and it is fast, up to 10 gigabits per second over 550 meters. So depending on the need, on your need, which one do you choose? Single mode more expensive, fiber multi-mode less expensive, but single mode can carry signals over longer distance than multi-mode. Fiber optic cabling are usually used in enterprise networks by service providers to provide internet connection to your home. Long haul networks, for example, a network that connects Canada to United States, okay? And submarine cable networks. Have you guys ever wondered how you're able to access a server in Singapore?
Yeah, one time we see I think in the lab we see a video how it wide and big they use it in the ocean.
Exactly. So the cables are laid under the ocean using submarines. This is how the internet is connected all over the world. Okay. So they use fiber optic cable in a long submarine network. The connectors on fiber optic cables are they're called straight tip connectors, ST connectors, LC simplex connectors, duplex multi-mode, or SC connectors. These are the four different type of connectors are used in fiber optic. Most common are SC connectors. So most probably you will see SC connectors. This is how fiber optic cable looks like. They're much thinner than UTP cable. There are different colors. This one is a patch cord,
Yeah, it's very delicate also. It's
and
very
they're very delicate.
yeah.
Very You have to be very careful to when you're installing fiber optic cable. Not everybody can do it. You have to take a course, such as our in our school telecommunication program. They teach how to install fiber optic cables. And it's not just that fiber optic cables are expensive to purchase, it's also the installation is more expensive because you need the expensive equipment and the training as well.
Yeah, I see. Janid added something information. The
Hmm.
machine we use it to do the cable to put the like RG
Okay.
45
Hmm.
is like 6,700. I see it was the guy who came to my home to do the fiber optic for the provider. It's expensive machine. The small, it's tiny small machine.
Oh,
And
yes, exactly. They're expensive. Yes, you're right. Because you need cutter, punch, punching tools. You need fiber optic cable meters to test the connectivity. All these equipments are expensive for fiber optic and can up to yeah can goes up to thousands of dollars, especially the meter. Okay, here's the bandwidth of fiber optic cable, fiber versus copper. Bandwidth supported, UTP cabling up to 10 gigabits per second, fiber optic 100 gigabits per second. But I think it has increased UTP cabling. Now UTP is also probably 100 megabits per second. Distance, UTP is short, fiber optic is long. Outside interference is low, it's high. Okay, completely immune. Immunity to electrical hazards, low, high, completely immune. Media and connector costs, lowest, highest. All the, so in a nutshell, fiber optic costs more, but it has advantages. So which one you should use, fiber optic or copper? There's no rule. It depends on your situation. Okay, if you have to have if the distance, if two networks you're connecting are longer than 100 meter per second, you have to use fiber optic, you see, because it is 1000. So you have no choice. So you have to justify the cost, meaning you ha you have to have a need to use fiber optic. Okay. Okay, wireless media. So instead of using cable, we can use wireless media. So wireless media, as you can say, much more convenient. It costs less. You don't need to hire people to come and install cabling. So why don't we use only wireless media? The problem with the wireless media is the coverage. it cannot cover large area. It is also susceptible to interference, meaning it can be the signal can be interfered by other signals, other wireless networks, even microwave, right? Walls, security is not very good in wireless network. People can steal the signal, and the signal uh, contains your password, your username, your banking information, and people can steal that information because it's all in the air. And it's a shared medium, so the speed, wireless networks are always slower than the wired network. So if you need high speed network, you have to use wired network. So for that reason, we still have a network that uses cables, not just wireless. So these are the different type of wireless media. So one is Wi-Fi that you guys connect to. Bluetooth is also type of wireless. Okay. WiMAX is also type of wireless, but it does not use very often. And Zigbee is another type of wireless network that nobody uses. I don't know anybody who uses it. The most common type of wirelesses are Wi-Fi that you connect to the your device to the Wi-Fi network, and also you connect to the Bluetooth. But Bluetooth, the speed is less and the range is also less. You cannot connect to a device if the distance is longer with Bluetooth. To set up a wireless network, you need a wireless access point or a wireless router, right? And a wireless network card. Most of the devices these days has built-in wireless network cards, like your cell phone, tablet, most of the modern laptop. Older computers, if you want to have a wireless connection in an older computer, you can buy a wireless USB network card that we have in a school. I think you guys have practiced with it, right? Have you guys created a wireless network with Dimitri?
Yes, yes, we do. In bucket tracer, we do one.
No, not on Package Tracer. We have wireless network card. Anyway, if you haven't, maybe
Yeah,
we will
but
do it.
we tried one when you remember the day we when we have like a problem with the internet, we tried to connect it by the the USB stick, but it not figure with Windows 11. So we tried, but it's not working.
Okay, so next time we will do it in Cisco Lab because we have Windows 10 here.
Okay, okay.
You should always try practice with real devices, especially when we have the real devices. Okay, packet tracer is excellent, but if you have, but as you can see, working with real devices, you encounter different problems. Okay, that you will not see in packet tracer, and your job will be to solving problems. So you will see more problems when you work with real devices. All right, so yeah, so we have wireless LAN, you need wireless access point or the wireless router and a wireless adapter which is built in. Okay, so this is the end